Hey everybody, and welcome back to another fun and exciting geometry class. Today we are going to be jamming 3 lessons into one. You're going to love this. It's 6.3 to 6.5, and it starts on page 264. All right, so let's jump into it. Go ahead and open up your books there, and then you can look down here on the screen. Theorem 76 says that regular polygons of the same number of sides are similar. This should make sense to you, kind of as we've been going through this. It should be like, yeah, of course they are. One reason is because, all right, so what does similar mean? Similar means that they're the same shape, but different sizes. So if we say that these are regular polygons of the same number of sides, they're both, in this case, this has 7 sides, so 1, 2, 3, 4, 5, 6, 7. So these are heptagons. And in these heptagons, we just learned in the last lesson that they're going to have the same angles right here because they're regular. So all you would do is plug into that formula and we could figure out what these angles were. And it's going to be the same in both of them. We'll do just a little quick review. That was 180 times n, which is 7 minus 2 over 7. All right, so 7 minus 2 is 5, so 180 times 5 over 7. We will need the calculator on that one. So I'll do 180 times 5 equals 900 divided by 7 is going to equal, let's see, 128.57. 128.57. Let's call it 129. We'll round that off. It's not perfect, but we'll call it good. So each one of those angles is 129. Now that's in both of them, 129 and 129. So that makes them similar because they have the same angles. So when they're similar shapes, when they're regular and they have the same number of sides, that automatically makes them similar, which automatically makes everything proportional. Look down here at Theorem 80. This is going to be on page 265 in your book. The perimeters of two regular polygons of the same number of sides have the same ratio, okay, as their radii or as their apothemes. Again, if something is similar, it means it's proportional. What does that look like when we're dealing with these things? Well, we have the center point, right? And that would be the radius, okay? So we'll label this one as the radius, and we'll call this one the radius prime. Well, we also have this other line that we talked about in the last lesson, and I'll make that a little bit better. Let's do this. There we go. And this one is called the apotheme. The apotheme is also proportional along with the radius. So we'll call this the apotheme 1, and we'll call this the apotheme prime. Now, the other thing that's proportional is their perimeters. What's that? The distance around the shape. Also, you could call their, let's say their sides are, let's say 7, and this one is 4, okay? So as soon as we know that, that means all of these are 7, right? We can also immediately find the distance around that because there are 5 sides. This is going to equal, and and the last one we had 7 sides, right? This one we're on a new shape, okay? So don't let that kind of play with your mind there, okay? So we're on to a 5-sided shape now. So we have 5 7s, so 5 times 7 is going to give us the perimeter for this one is going to equal 35. So that's perimeter. In our perimeter prime, so this is our prime shape over here, we're going to have this one's 4 times 5. So 5 times 4 is going to equal 20. So our perimeter prime equals 20. Okay? So again, these are proportional. What does that mean? That means we can set these up as a proportion. So the perimeter was 35 over 20. That's the perimeter prime. Now, if we know one of the radii, then we can figure out the other one. If we know one of the apothemes, we can find the other one. Let's just randomly say that we know that this one is, we'll call this 6. So what we would do is we would just plug that in. Now this is, again, this is the non-prime shape. This is the original shape. So this one equals 6 over, well, we don't know this one. That's what we're looking for. So our prime, or we could call that our x, right? So we would solve this using our proportions. How do we do that? It's 35x equals 6 times 20. So 35x equals 120. Then we would divide both by 35 and 35. And we would come out with x, or our prime, equals this right here. We'll do this on the calculator. And 120 divided by 35 is going to equal 3.42. We'll call that 3.4. And you would round that to whatever it asks you to round it off to. So in our prime shape, our radius would be 3.4. We could do the same thing with the apotheme. Now, another thing that we could do it with, let me erase this real quick down here so you can kind of see it, is if it makes sense, we could also do it with the actual side itself. We could have just used 7 and 4 as our ratio, because look, we just have to reduce this one, because this perimeter was 35 over 20. If we reduce that, right, it gives us our sides. What was our sides? 7 over 4. Okay, so we could also add to this one, let me kind of add this over here, side over side prime. That's another one that works here. You need to write this down. Perimeter over perimeter prime equals radius over radius prime equals apotheme over apotheme prime equals side over side prime. Those are super important. You're going to be using those all the way through these exercises. Okay. Next, jump over there to corollary 80.1. And it says here that the perimeters of the two regular polygons of the same number of sides have the same number of ratios corresponding sides. We just talked about that. Okay, I just wrote that right here basically. And that was just kind of a deduction that we made from this information. We kind of deduced, okay, well, it also makes sense that the side would be part of that. That's what corollaries are. Corollaries are just deductions from the theorem. It's like, okay, the theorem says this, then that means that this also has to mean this. There's no other way around it. So if you're kind of, and I know we're deep into the year, but if you're still kind of trying to figure out what these theorems are, the theorems are statements that are always true, right, using geometry. And then the corollary is like a statement about the theorem that is very easily deduced most of the time. Sometimes it's a little bit more complicated to deduce them, but they're statements that come from the theorem. All right, so here we go. That means that the perimeter over perimeter prime is going to equal the side over the side prime. Continuing on that same thought, the areas of the two regular polygons are to each other as the squares of their sides. That should also make sense, because what is area? Area is always squared. So if we take the area, then we have this. So when we're dealing with perimeter, this is the one to focus on right here. Perimeter equals radius over radius prime equals, okay, and so on. But when we're dealing with area, check this out. It's the same except for everything is squared. So you're going to have radius squared over radius prime squared. You're going to have apothem squared over apothem prime squared. And then you would also have, perimeter over perimeter squared over perimeter prime squared. That would go here. So you need to write this one down too. Okay. Another way that you could do this is you could also write, going back to this one, you could write your area here as a square root. So you could write the square root of area over the square root of area prime. Okay, and so that would work there too. So you can always find the area by square rooting it if you're dealing with the perimeters, and then you can always find the perimeters by squaring it if you're dealing with the area. So that's the way that that works. That's a very important kind of train of thought right there. Okay, so sometimes they're going to give you the area and you have to find the apothem. Okay, sometimes they're going to give you the apothem and you have to find the side. Okay, anywhere in that is a possibility that they could make you connect one to another. All right, then the last thing for this lesson, if you will go ahead and turn to page 266, this is lesson 6.5, area of a regular polygon. Now, we've learned all kinds of different area formulas at this point. This is just another one to kind of add to your list. Theorem 81 says the area of a regular polygon is equal to half the product of its perimeter and its apothem. Another way to write this formula would be, and they're using K to signify polygon because P is already used for parallelogram. So we're going to just use K. So we'll say K equals AP over 2. You could do that too. I like this one better. Your book uses this one, but I kind of like the divided by 2 a little bit better. So you just do whatever you want there. But that's the way that you solve that. You take your perimeter times your apothem and you divide it by 2, and you're going to get the answer. You could also multiply it by 1/2. Same thing. Multiplying by 1/2 is the same thing as dividing by 2. All right, so what does that look like? Well, you need to sometimes, here's what they're going to do. They're going to make you find this apothem. You're not going to know what it is. They're going to give you the radius. They're going to say radius equals 5, for example. And then they're going to say side equals 8. I'm just throwing numbers out there, okay? And you need to find what? You need to find the perimeter. Well, what does the perimeter equal? Well, 1, 2, 3, 4, 5 sides to this thing. So we're going to say 5 times 8, and that's going to give us a perimeter of 40. So now we know our P. So here we would write 40, okay? And then we have to figure out what the A equals. We know it's going to be divided by 2. You could divide that by 2 right now if you want. So you could say times 20. So, you know, I could kind of delineate this, and I'll do that in just a second. But for right now, the A is the missing part. How do we figure that out? Well, it's not as hard as you might think because we kind of have some information. What do we have? We have a right triangle right here, okay? Remember that this is the midpoint. It has to be the midpoint. So in other words, this piece is going to be 4. So we have a triangle that looks like this. The hypotenuse is 5. This side is 4. And we need to find this missing piece. How do you do that? You do that with Pythagorean's theorem. A squared plus B squared equals C squared. Well, C squared is going to be our 5, right? So that'll be 5 squared. And then it doesn't matter which one's A and which one's B. We'll call A 4 squared and then plus B squared. Now we want to get B all by itself. So we're going to subtract 4 squared from both sides. And that's going to be B squared equals, and we'll just go ahead and solve this. That's 25 minus 16. B squared equals 25 minus 16 is 9. So in order to solve that, we would take the square root of both sides, and we'd get B equals 3. All right, so there we go. Lots of math. I told you there was going to be math in this lesson, right, in this section here. So B equals 3. Now, technically, B equals positive and negative 3 because you could get from this, you get positive and negative 3. But in this case, we just need the positive because we're dealing with real measurements. We're dealing with an actual triangle in real life. So it has a length of 3. You can't have a negative 3-inch triangle. It just doesn't work. So you have, in geometry, you always only deal with the positive values. So 3. Now let's go back up here. So that equals 3. We're not done yet because we have to plug that into this formula. All right, so here we go. K equals this. Now, I can just go ahead and cancel this down to 20. So 3 times 20, that equals 60. Now, remember, it's in area, so that's going to be squared. Let's call it just units squared. We don't know. We never said if there were inches, feet. We didn't say that. So 60 units squared is the area. So K equals 60 units squared. That's our area for this shape based on the information that we had. The given information was the radius was 5 and the side was 8. We figured the perimeter out. We figured the apothem out over here, and then we plug that into the formula to get our answer. So lots going on there, but I think it's things that you can handle. It's formulas you've used before. It's proportions you've used before. It's the concept of area is always in squared. We've done that before. So this is just kind of putting together a bunch of things in order to find the answers to these problems. All right, so work hard, try those practice problems, do your best. If you missed anything, slide it back, watch it again. That's all I've got for you. Have a good one. Bye-bye.